Hello, everybody. Today we are going to learn about rotary controlling circuits. As shown in the figure, if the two start buttons SB1 and SB2 are accidentally pressed during the operation of the line, the main contacts of the two contactors KM1 and KM2 will be closed simultaneously due to the power supply of the two contactors, resulting in the occurrence of a short circuit between the main circuit power supply phases. A fuse refers to an electrical appliance that fuses the melt to break off the circuit with its own heat when the current exceeds the specified value. The function of the fuse is to protect the line from short circuit, which is an electrical fault caused by damage to the insulation of the electrical equipment or wires. When in use, the fuse should be connected in series in the protected circuit. Under normal circumstances, the melt of a fuse is equivalent to a section of wire. When a short circuit fault occurs in Analysis 2. Through the above logical reasoning process, it can be concluded that when a motor is under forward and reverse control, one contactor coil branch of the two contactor coils under forward and reverse control is energized, while the other contactor coil branch cannot be energized. That is to say, the power on and off of the two contact coils KM1 and KM2 are mutually restricted, and this restriction can only be achieved through the contacts of the contactor itself. The fuse mainly consists of three parts: a fuse seat, a fuse tube for installing the melt, and a melt. The melt is the core of a fuse. It is often made into filaments, sheets, or grids. The materials used to make the melt are usually lead tin alloy, zinc, copper, silver, etc., depending on the requirements of the protected circuit. The melt tube is a protective shell of the melt. Composition characteristics of contactor interlocking link. 1. Use the normally closed contact of the contactor. 2. Connected in series to the power supply branch of the contactor coil. 3. Each other appears in the power supply branch of each other's contactors. The above is the relevant knowledge of fuses. There are various forms of thermal relays, with bimetallic sheet type being the most commonly used. These are several common thermal relay profiles, all of which are bimetallic sheet type. Each series of thermal relays can generally only be used in conjunction with the corresponding series of contactors, such as JR20 series thermal relays used in conjunction with CJ20 series contactors, T series thermal relays used in conjunction with B series contactors, etc. KM1 coil is powered on. KM1 self-locking contact closed, self-locking, KM1 main contact closed. Motor M starts continuous forward rotation. KM1 interlocking contact braking for KM2 interlocking. 2. Reverse control. Press SB1 first, KM1 coil loses power. KM1 self-locking contact braking to release self-locking, KM1 main contact braking. Motor M loses power and stops running. KM1 main contact braking. KM1 interlocking contact is restored to closed, and KM2 interlocking is released. Press SB3 again, and KM2 coil will be powered on. KM2 self-locking contact closed, self-locking, KM2 main contact closed. Motor M starts continuous reverse rotation. KM2 interlocking contact braking for KM1 interlocking. When stopping, press the stop button SB1, the control circuit loses power, the main contact of KM1, or KM2, breaks, and the motor M loses power and stops running. Definition of contactor interlocking: when one of the contactors is powered on and passes through, its auxiliary normally closed contact prevents the other contactor from being powered on. The constraint of this interaction is called interlocking or interlocking. Characteristics of contactor interlocking circuit: its advantage is safe and reliable operation, the disadvantage is inconvenient operation. Because of the switching between forward and reverse rotation of the motor, the stop button must be pressed first before switching between forward and reverse rotation. Otherwise, under the interlocking action of the contactor, the motor cannot switch between forward and reverse rotation. Contactors are automatic electrical appliances that use electromagnetic suction to frequently connect and disconnect the main circuit of electric motors or other electrical equipment. The contactor consists of four parts: electromagnetic system, contacts. The figure shows the graphical symbols of thermal elements, normally closed contact, button interlocking forward and reverse circuit diagram. The symbols for the contactor coil, main contact, and auxiliary contact are as follows. and reverse directions. The disadvantage of button interlocking circuit is that it is prone to phase-to-phase short circuits. Here's the problem again. Can direct switching between forward and reverse rotation be achieved on the basis of interlocking the forward and reverse circuits of the button, while also avoiding phase-to-phase short circuits? Think about how to achieve it. Yes. It is the combination of contactor interlocking and button interlocking. This is the circuit diagram of the double interlocking forward and reverse lines. Let's analyze the control process. Forward control. Press SB2. SB2 normally closed contact first breaks and interlocks with KM2, cuts off the reverse control circuit. After the SB2 normally open contact is closed, the KM1 coil is powered on. KM1 self-locking contact is closed, KM1 main contact is closed, and the motor starts continuous forward rotation. KM1 interlocking contact breaking for KM2 interlocking, cutting off reverse control circuit. 2. Reverse control. Press SB3. SB3 normally closed contact first breaks, KM1 coil loses power. KM1 self-locking contact disconnected to release self-locking. KM1 main contact breaks, motor loses power and stops forward rotation. KM1 interlocking contact returns to closed, SB3 normally open contact closes afterwards. KM2 coil powered on, KM2 self-locking contact closed self-locking. KM2 main contact closed, motor reversed. KM2 interlocking contact breaking for KM1 interlocking, cutting off forward control circuit. From the figure, we can see the composition characteristics of the double interlocking forward and reverse lines. Which double is in the double interlocking forward and reverse circuit? 1 is an interlocking system consisting of a normally closed contact of an AC contactor connected in series with another coil. Another aspect is the interlocking formed by the normally closed contacts of composite buttons connected in series in the other party's circuit. The dual interlocking forward and reverse control circuit adds contactor interlocking on the basis of button interlocking, forming a button and contactor dual interlocking forward and reverse control circuit. This circuit can effectively compensate for the shortcomings of button interlocking and contactor interlocking forward and reverse control circuits. But the composition of the line is relatively complex. That's the end of this class. See you next time.